Swayam Prabha. Digital India. Educated India.
So, so this is what a basic block could look like. A control flow graph could look like. So now, if I give you some statement x equals 1, y equals 2, the same statement what I saw earlier, x greater than x plus y less than 5, then x plus equals 1, y plus equals 2, else like output. So I am not seeing it as a function call, but just a way of returning values, x and y. So now can you tell me that what are the different basic blocks in the program?
One would be like including x equal to 1 and y equal to 2.
Very good. So one is including.
And yeah, then it would be based on the if condition, basically, like if x plus y is less than 5.
Right. So that will be something like this. And then this is a basic block, and then this is
Then the output.
Excellent. And if I label them A, B, C, D, can you give me what the graph will look like? So I will have an edge from this to this, because as soon as exit this, I can come here. There will not be an edge from A to C, because I cannot directly jump from A to C anywhere. I'll have to execute through B. So I will not put an edge. But from B, I can directly jump into C, right? Because if the condition is true, I'll jump there. And if the condition is false, I'll jump here, right? And if there is a final return or something like that, then this is also basic block. Then there will be edges going from C and D to E. Right, so this becomes a basic block, right? So the basic block looks like A. From A, I can go to B. Then from B, I can either go to C or I can go to D, depending on how my branch turns out. And then I finally come to E. So this is what my control flow graph looks like. There is a small thing here, and generally we will do this analysis on 3-address code, because otherwise there can be a statement which does multiple things, and then it becomes slightly difficult to say which basic block should belong to. Like, for example, if you have a if statement, it does two things actually, if you think about it. It does a check. It does try to do a check to find out if this condition is true or false. And then it does a jump. Like, depending on the condition, it tries to jump to either C or D. So if you think of, if I break it into these two parts, in some sense, you can see that the check can go to this part, right, to the A basic block. Because no matter what, I have to do that check, right? I cannot like execute y equals 2 or x equals 1 and not do this check of x is less than equals 1. And then I will have to do a jump. So, I mean, one of the jumps may not be like, in some sense, there are two jumps, one goes to C, one goes to D. So one of them you can take as a fall through. But either way, it is possible that one of the jumps is not hit, right? So this will be, see, this jump will be a separate basic block, but the check will go to the basic block in A. So what we will do is that instead of using this structured representation, I will say we will analyze on something like 3-address code. I'm sure you have seen 3-address code in your compiler's course. So 3-address code essentially is a representation where we exactly have 3 addresses, where I say that x and y are 2 operands, and plus is an operator, and this is the resultant. So there are 3 addresses, x, y, and c. Yes, there was a question.
Why can't we just include the jump in the first basic block? You can jump at the end of a basic block, right? And it's only one jump instruction.
That's a very good question. So that depends on how I'm writing that jump. So so the one way to write this jump would be that, let's define the statements in 3-address code. So I'm saying I have an assignment statement, and I'll just come back to your question. So I can have an assignment statement, then For these jumps, I will introduce goto statements. So I will have an unconditional goto statement which says goto to some label L, and I'll have a conditional goto statement which says that if some condition is true, then go to L. Right? So let us say we have only these three statements in my three address code. Right? So now if I write this particular program in my three address code, what would it look like? I have x equals 1, which is very much a three address code statement, so that is good. I have y equals 2, so that is also fine. So now I cannot write an if x is this, then this condition, then this condition. So I'll have to compile it down to a sequence of jumps. So I'll have to say that if x plus y is less than 5, then go to some label L1, and then I say go to some label L2, and then I can say the label L1 essentially looks like, again I could have written it differently, and then the basic block could have differed, but the label L1 could be essentially pointing to my basic block C, which is nothing but x plus equals 1 and y plus equals 2, and my basic block L2. So now I'll have a go-to statement, say L end, and I have L2, which is the other part, which says output of x comma y, and then again, so this can fall through into L end, and L end simply does a return. Right? So just coming back to your question, for example, so this does a jump, and it does a check and then a jump to some. So this is a conditional statement. So you are very right that this particular statement can come within the basic block. So this can be included in A. But then this particular jump statement, which jumps to the other direction, that cannot be part of it. Right? Because like if you're executing this, if you're executing x equals 1, there is no guarantee that we will be end up executing go to L2, because it can happen that this condition turns out true and I actually escape into L1. So then this go to L2 will have to become a different branch, has to become a different basic block. Right? And you can see that I cannot merge go to L2 with anything else. Right? There is no guarantee that, in fact, whenever you do go to L2, you'll not even execute this next statement. Right? So there is no way that this can be part of this basic block. So I'll have to put it in a new basic block. Right? L2, of course, if you do a go to L end, so the go to can be part of this. But when I do a go to L end, of course, L2 cannot be part of this basic block. So this has to become a different basic block. Right? And what about this particular statement? Why does this have to be a separate basic block? Can somebody explain?
Since it's used by both the blocks like L1 and L2.
Yes, because I need to jump from both the places into this. Right? So I cannot merge it with any place, because if I merge it with L2 and make it a basic block, in that case, there is no guarantee that you execute L2. It can happen, you jump in the middle of the basic block and execute L end. So it should be the case that in a basic block, either all statements are executed or no statements are executed. You cannot do that some statements are executed and some statements are executed. So I cannot merge it with any of these things. Right? So this then becomes our control flow graph. So then I have an edge from A to this particular guy, and I have an edge from this to L1, and then I have an edge from L1 to L2. I cannot have an edge because L end will always take me outside L2. So I'll have an edge directly going to L end, and I'll have a fall through edge from L2 to L end, because after the execution of output XY, this guy has nowhere else to go but to come to L end. Right? So there is an implicit edge here. Right? There's an implicit control flow here. And then after you execute these, and of course there is another edge going from L2 to this target. Right? So this becomes our basic block. Does it answer your question? So this is a very important part. Please understand it. We can spend more time on it, but this is really important for the rest of the course. For the next 1 week, you will see a lot of control flow graphs, and every single analysis that you do will use a control flow, or almost every analysis will use a control flow.
Could you please explain how it's linked, like go to L2 is linked from A?
Yeah, okay, let me just clean this up a little bit. So let me use a different color. So let me say that this is a bad color. So let us say this is basic block A, This is, let us say, basic block B. This is, let's say, basic block C. Let's say this is basic block D. And the last one, let's say, is basic block E, right? So we have 5 basic blocks. So so from the basic block A, I can take this, go to L1, right? And I can jump to C, right? So that's a possible way. And that is one way to escape the control flow. I can go from A to C. The other possibility is that this condition turns out to be false. And if this condition turns out to be false, then I have no other place to go but to B, right? So there is a implicit control flow going into B, right? So then from A, there are 2 edges, one going to B, one going to C. Now, if you go to B, now B has nowhere else to go other than go to L2, which is nothing but D, right? So B needs to go to D. There is nowhere else it can go. Now C, let us take C. Now C also cannot go to anywhere else but to go to end, whichever is E. So C must go to E. C must go to E because it is going to go to Ln, right? And from C, I cannot go to D because there is an unconditional control flow, right? It will always force me to go to E. It will not allow me to go to D in any case, right? So there is no control flow between C and D, right? And after executing D, like after you have executed this output, there is nowhere else to go but to execute to the next statement, right? Again, there is implicit control flow between D and E. So then this is your control flow graph. Are you clear?
Yes, thank you.
Okay, excellent. Right. So then we know how to make this control flow graph. Once we have this control flow graph, and this control flow graph is a pretty cool thing. I'm sorry I completely destroyed the graph behind it, but let me just ask you some question. But I think it's still sort of visible. So can you look at the control flow graph that you see behind this large graph that you see behind, and tell me. So what I've done is I've blanked out the statements. I do not care what the statements are. That is what we said, that when you do a control flow analysis, I don't care what are the statements sitting inside the basic blocks. Once I've created the control flow graph, that is all you need. You can throw away the statements. I will not care about them. While creating the control flow graph, of course you need the statement, because without them you cannot create the control flow graph, because you need the control statements, how go-tos are flowing. But after you have created the control flow graph, then you do not need the statements at all. You can just simply throw away the statements. Now, so I have completely thrown away all the statements. I have just represented them with some names, 1, 2, 3, 4, some IDs. Now, can you just look at this particular statement, this particular basic block, and tell me what is the statement it must contain? Can you tell me at least one statement this surely must have?
Some looping statement.
I'm talking about 2.
Okay.
It must have a branch because it has 2 paths that it can go to.
Yes. So it must have a branch because it has, so then it must have a branch because it has, it has 2 outgoing edges, right? So like there is a possible, so there must be a way of, it is some sort of if then else statement, right? Which is going to 2 parts, or at least a if else statement. In fact, you can also say if it's an if then else statement or a if else statement. Can you tell me that if does it look to be an if then else statement or a if else statement? So I'm now forcing you to go higher. So we did this on a 3 address code, but then even looking at the control flow graph, you should be able to understand the C structure, the structure of the C code. So it's that descriptive. So can you tell me whether it looks like a if then else statement or a if statement? So, okay, I'll leave it as homework. So I'll leave it as homework that try to tell me if this is a if then or if then else. Try to create a if the control flow graph for a if then else statement, create a control flow graph for an if else statement, and then try to study it. So your question as to there is a looping somewhere, that is also true. I sort of missed it. So I can see there are these 2 back edges coming in. But can you look at this particular loop and tell me the type of the loop, whether it is a while loop or a repeat until loop? What does it look like?
It's a repeat until loop because either it's a repeat until or it's a do while loop, because the condition is being checked at 2.
Yes,
It's
yes, yes, yes. So yeah, so C maybe the repeat until is written as a do while. Other languages we call it repeat until. So this is like in C language, this is something like a do while loop, right? Because it is the condition is being checked at the end and it goes out, right? So it looks like it's a do while loop. I'll give this answer that it is actually an if then else statement. There is another loop, and this looks to be a nested loop, right? One loop seems to be contained within the other. So even without knowing the statements, I could tell you so much about the program, right? And can somebody tell me that what does this particular edge signify? What could be this particular statement 4? Maybe that is again homework. Try to tell me what this basic block 4 must be. I think you switch on your mic again. I think it will be okay. Because I think both of us were talking.
I think
Oh, there is still a disturbance. Okay, so okay, so think about it. Think about it. What could this statement 4 be? So that's a homework. That's a homework. So homework is tell me what statement 2 is, and tell me what could be what must be there in statement in basic block 4. And all I'm trying to say is yes, exactly. It's some form of break. And so all I'm trying to say is that, see, even looking at a control flow graph, you can say so much about it, right? You can say what the program must look like. At least you can tell me all the control flow constructs. There is a while statement, where there is an if statement, where there must be a break statement, where there must be a continue statement. You can say a lot of things about it. You may not tell me the assignments, but other than that, you can tell me the structure of the code, right? And that is why this control flow graph is so important, because it tells you so much about the structure. So next we will try to see how to construct this control flow graph. The way to construct this control flow graph is to take this stream of instructions and then identify what are called leaders. That's the main thing. Once you have got leaders, then it's just breaking things as per leaders. So let me just explain the algorithm very, very quickly. So let me just take the same example that we had so that we don't use different examples. So I have x equals 1, y equals 2, then we have if some condition, I don't worry about what the condition is, because again this is control flow graph. Then go to L1, then go to L1, then you have go to L2, then you have L1 x equals x plus 2 and y plus equals 2. This is L1. Then you have go to L end. Then you have L2. What does L2 have? L2 has output xy. Then we have L end as a return statement. Right. So let us say this is the control flow graph. So the first thing to do is to identify what are called leaders. What are leaders? So if you have the first instruction, so the first instruction in a program, in the procedure, is always a leader, right? So that's first rule. The second rule is targets of jump instructions. Whenever you have a jump instruction and you're jumping to a label, so any label that is a target of a jump instruction, and most of the times you will have labels, and like if you have a label, very likely there is an instruction jumping into it. So then any target of a jump instruction is going to be a leader. And instructions following jump instructions, no matter what jump instructions, either it's conditional jump or unconditional jump, any instruction following that jump condition is going to be a leader, right? So these are the 3 rules of leaders. So let us go to this program and find out what are leaders. So this thing So this particular thing is a leader. Why is this a leader? Because it is the first statement in the procedure. This statement is not a leader because it does not satisfy any of the conditions that we talked about. This statement is again not a leader. This statement is a leader because why is it a leader? Because of rule 3. It is because of rule 3, which is instructions following any jump instruction is a leader, right? So this is a jump instruction, like it's a conditional jump instruction. So this statement is following that, so this must also be a leader. L1 is a leader. This statement is a leader because this is a target of this jump. Remember, targets of jumps must be a leader, so this must be a leader. This is not a leader because this does not satisfy any of the conditions. This is not a leader, that does not satisfy any of the conditions. This is a leader because this is a target of this jump instruction, right? So this is also a leader. And this is also a leader because this is a target of this jump instruction. That's it, right? So you identify which are leaders. Next thing you do is very simple. You just break things at leaders, right? Just before the leaders, you try to start creating boundaries for basic block. So this is my first boundary because that was a leader. The next leader is this one. So then I create the next boundary till before the next leader. Then I create the next boundary till the next leader. Then I create the next boundary till my next leader. And then I create my next boundary till my next leader. So these are my boundaries. Between any of these two boundaries becomes a basic block. So these are all basic blocks. And then you know how to, and these are the exact basic blocks, remember what we created here. And then you know if there is a potential of transferring control from one to the immediately to the other, then we call it then there is an edge between. So that is my control for that. That's the end of the story. What is the entry edge? The first statement. Any basic block which contains the first statement becomes the entry edge. Right. So now, if just to complete the story, if I have A, B, C, D, E, then we already know how to create these edges to create the edges. So the only trick is identifying which are the basic blocks, and the crux to the story of identifying basic blocks is to identify leaders. How do I identify leaders? There are three mantras to identify leaders. Just remember the mantras. That's it. Any questions with this algorithm? Anything that might not be clear?
I have a question.
Yes.
What if the only instruction in a basic block is a jump instruction?
Then it is a leader. That it's a basic block, so it's okay. So this is such a basic block. See, this has nothing but a jump instruction.
Would that be still? Yeah.
It is still a basic block. Yes, it is still very much a basic block.
Okay.
Yeah, like this basic block B is exactly that type of basic block. See, basic block B contains only the jump instruction and nothing else.
Okay.
Okay.
So good questions. Thank you for the questions. Right. So then, like, we just to finish the story, I mean, we accumulate all the basic blocks, the statements in the basic blocks, and correct them, and we got the control flow. This is an extremely important data structure, and I repeat it multiple times, and I'll not shy away from repeating it more. Because like the next whole week, you will not understand anything unless you understand what is a control. So I can take a small stop here, and I can let me go for another 2-3 minutes, and then I'll get into the break. But I can take a pause here and ask you if everybody has understood. This is extremely important. So in some sense, this lecture is a connection between like whatever you've done till now to the next lecture, and it's very important that you get this connection right.
So I have a question regarding the
Yes.
we define the basic blocks and their edges depending upon like how we define the instructions, the branch instructions also. So is it always the case with the representation with the how we represent the code, the basic blocks or the CFG series?
That is a very good question. That's a very, very good question. Yes, that will, like, the form of a three address code, what our three address code or any other intermediate representation looks like, will sort of dictate what your CFG would look like. But still, you can think that if you have a high level program, you can still see what it would essentially break down into. The problem with high level code, like something like C, is like certain statements have multiple effects. They do checking and jumping at the same time, and they need to be segregated into different basic blocks. That is the only reason. But no matter what is the type of your control, your three address code or any other intermediate representation, generally there is always these category of statements. There is some sort of an assignment statement. There is some sort of a unconditional jump. There is some sort of a conditional jump. So these statements would be there, right? And their syntax might be different, their semantics might be different, slightly differing on what is the representation you're choosing. But more or less, these elements are there. And so these concepts, though I still would say that they are dependent on your intermediate representation, what your intermediate representation exactly looks like, but they are still a little generalizable, because mostly all intermediate representations look very similar in terms of their selection of statements, because all of them will have some sort of an assignment, some sort of unconditional jump, some sort of a conditional jump, some sort of a call instruction, some sort of return instructions. They will have just like this. They might look different, but there would be category of such statements. And so no matter what your intermediate representations are, your control flow graphs for the same code will look similar, if not same. Right? Does that sort of answer your question?
Yes, sir. Yes.
Okay. Thanks for the question. This was a very insightful question. This was a very, very nice question. And in some sense, so can somebody tell me whether this is a control flow analysis or a data flow analysis? Control flow graph construction? Yeah, so it's a tricky question. So the thing is that here you need to only look at your labels, but you never will have to worry about the value sitting inside the variables. Because I do not care about this condition, like if this condition was x plus y is less than 10, I never will have to evaluate it. I can just say there is some condition, because I have to take both the branches, whether when it is true and when it is false. So both it will have edges to both of them. So this is still a control flow analysis, right? But it requires these labels, where the labels go. But this is a part of control flow. Like jumping to a label is a part of control flow. It is not part of a data flow. Right? So this is still a control flow.
So I have a follow-up question for this.
Yes.
So if we have, suppose that if condition we set it to 0, always like suppose that it will not be taken anytime, then still in the CFG there will be this C node where we will jump to L1.
Very good question. Very good question. Very, 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 very good question. So if you have something like if false, then go to. So the point is that like you do two things. Either you do an optimization or you eliminate it completely. That is one way to do it. But once you're doing when you're doing control flow graph construction, in that case, the control flow graph construction will never look at what is the condition. It will never try to interpret the condition again. So it will still assume that it can both be true and false. So there can be some branches in the basic block, in the control flow graph, that will never get executed. That can happen. But it is surely we will not be missing any branches. There will be no branches that we missed out, but it is possible that we do not execute all the branches that are there. It is not possible to execute all the branches. So when you're doing control flow analysis, you're not allowed to reason on the values of different things. The value of a condition, the value of a variable, you're not allowed to look at them. So yes, to just go back to your question, yes, it will have a branch edges to both sides, the true side and the false side. Thank you.